Hello everyone, it's NetMaven. Today we're going to talk about is Cisco NDFC Nexus Dashboard Fabric Controller for VXLAN EVPN multi-site deployment. Well, you see here the Cisco Nexus Dashboard login page. Cisco has rebranded the Datacenter Network Manager DCNM as Nexus Dashboard Fabric Controller in version 12. Cisco Nexus Dashboard, which installed the Fabric Controller NDFC, offers a network management system (NMS). So it supports for transition and multi-tenant LAN and SAN fabric on a single window. The Cisco Nexus Dashboard Controller NDFC can work across all Cisco Nexus and MDS switching for storage families. It manages large numbers of devices, providing a ready-to-use control, management, and automation capability, including VXLAN is what we're today going to talk about for automation Cisco Nexus LAN fabrics. And more, it supports automatic configure for multi-tenant automation. Let me just log in for you. So the first time I started the NDFC from the Cisco dashboard that displays the feature management, what you're gonna do is navigate to the fabric controller. Then what you're gonna do is navigate setting and a feature management. What I'm gonna see is we have the feature enabled endpoint care, performance monitor, VM visualizer, fabric builder. They are all enabled as for now and is enabled for Fabric controller. Now let's talk about today's diagram. On the left side we have a green field, which is what I'm building today. And we have brown fields where existing network is. They're all running as VXLAN. So what is VXLAN? VXLAN is overlay technology for network visualization. It provides a L2 extension over the shared L3 layer infrastructure network by using the MAC address in the IP UDP tunnel encapsulating. So what you see here is as an IGP providing the L3 network. And we have VXLAN, and it's the tunnels through to the other L2 network by using the MAC in IP. So the purpose is to extending the L2 in the overlay network is to overcome the limitation of the physical server racks in a geographical location boundary to achieve flexibility for workload placement within the data center or between different data centers. So whenever there's new switch, new controller, new server plugged into the VXLAN, they will have define a multicast-based flood and learn without a control panel. So it relies on the data-based flood and learn behavior for remote VXLAN tunnel. So we call it VTAP. And the VTAP will discover and remote ending host learning. To overlay the broadcast unknown unicast and multicast traffic, we call it bomb traffic. Broadcast, unicast, and multicast traffic will be encapsulated into the multicast VXLAN and transported to the remote VTAP. We are gonna do a underlay multicast for forwarding. So the underlay is either IGP, IIS, OSPF, whatever you have, and I will also going to enable the ping for the multicast. It can be such a challenging for scalability of the solution. So the requirement is to enable the multicast capability in the underlay network. So that presents a challenge because some organizations do not want to enable ping or multicast within the data center or over the WAN network. There's no multicast. So to overcome the limitation of the flood and learn VXLAN, the organization can use multi-protocol border gateway, we call it MP, BGP, over the Ethernet Virtual Private Network, EVPN, as a control panel for the VXLAN. So the MP, BGP, EVPN acts as a standard-based control plane for the VXLAN overlays. The MPBGP control plane provides the protocol-based VTAP, peer discover, and end-host reachability information distributes for the VXLAN over, and it allows more scalable VXLAN overlay network design suitable for the private and private cloud. So this will be through a MP BGP peer between the spines. There will be former MP BGP. So the VXLAN EVPN multi-site feature is a solution to interconnect two or more BGP-based Ethernet VPN EVPN sites fabric in a scalable fashion OPD over the IP only network. And we are having a BGW, which we call the border gateway, is a node that interacts with the nodes within the sites, within the spine sites, and it connects as a external to the other sites. So in overall, is a leaf and spine architecture data center fabric, and it can be a leaf spine and a separate device as a BGW, acting as a gateway to interconnect the sites. So let's talk about this lab. We will use the fabric controller in the green fields. This is we're gonna do to provision the new VXLAN EVPN fabric in the greenfield site, and we're going to import and deploy VXLAN EVPN fabric for the greenfield. And we're going to create a brand new and logical interface. So in the last, in this case, we will be creating a VPC interface from my site 1 leaf 1 and site 1 leaf 2, and it will be creating is the VPC. And we're seeing here the site, the border leaf 1 is in place to provide external L3 connectivity using the VIF Lite to the external L3 site. And I'm going to extend the classic Ethernet network right here to a VXLAN BGP EVPN fabric. Then we're going to including migration of the first hop gateway. The gateway is going to be the VXLAN, which is in turn facilitating moving workloads from the old network to the new data center. And we'll see the right side here is a brownfield site. So we're gonna show you how to migrate an existing VXLAN BGP EVPN fabric to Cisco fabric controller. And the transition while having is migrating existing network configuration to the fabric controller. So I will create and manage the fabric using mutual CLI configuration or customer automation script. So now I can manage the fabric through the NDFC, the fabric controller. Gonna migrate to NDFC. And the NDFC manages the fabric underlay and overlay network, and we're gonna import and deploy brownfields to the NDFC. So we'll remove the bucket creation and network VIF. For the next step, we're gonna use the fabric controller to create the core fabric. And we're going to create the multi-site. The multi-site connection includes the border gateway site 1 and the border gateway in the site 2. And then we're going to create the border gateway connections to the core router. So we're going to form a multi-fabric container that created to manage multiple member fabric. So this is a single point of control for definition of an overlay network and a VIF that member the fabric share. See, we have the blue net, and with blue net we can share crossing the fabric. So let's get it started. The first thing we're gonna do is import and deploy VXLAN VPN fabric on the green field. We will import a clean fabric and configure VXLAN BGP VPN in the site 1 green field using the fabric controller. So the fabric controller clears all configuration on the switches except the management before pushing the VXLAN EVPN configuration out to the switches. So I will show you how to achieve this configuration of the fabric using a flexible customer template based framework. So with a minimum user imports that I can bring up the entire fabric with the Cisco recommend best practice configurations in a short time period. So just with a set of parameters exposed when creating a fabric in a fabric setting that allows me to tailor the fabric to my preferred underlay provision options. So in the fabric controller, I'm going to navigate to LAN and the fabric. We're going to create a new fabric. The fabric name is site 1. Greenfield. The template, we're going to select Datacenter VXLAN EVPN. So in a general parameter tab in the BGP ASM fields, we're going to insert our BGP 65111. And for the underlay, we're going to scroll down for the underlay subnet IP mask. We'll select 31. So we have 2 usable host address. Then we're going to select the replication. In the replication, we're going to change underlay RP loopback ID to 251. As for this step is to suspect the multicast RP loopback ID. Then let's scroll down. Go to Advanced. Scroll down, we're going to navigate to Greenfield Cleanup option. We're going to select Enable. Go up and we're going to select the resources. The resources, we're going to scroll down until I see the VIF Lite deployment. So scroll, we're gonna used is the back-to-back to external. So when select this option, the Fabric controller can automate configuration on the external device if it is the NXOS or ASR 9K for the VF Lite extension, auto for VXLAN, EVPN Fabric. So go to the bottom up here and we're going to click Save. Now I find that I successfully created Site 1 Greenfield Fabric. The next step for the Greenfield Fabric is to discover and import switches that make up the fabric. We use a seed IP address of a switch in the fabric, and we use the seed IP address of a switch. So in this way, each switch is an equal distance from each other. So a switch in my fabric is selected, and the fabric controller lets me to define an expected hop count to reach all switches in my fabric for discovery. So this discovery occurs by giving me access to the switch through the local admin using the AAA user or the local user. So it set up the fabric setting. So if this user must be able to SSH to the switch and will perform SAMP v3 queries and will show around the commands. So this user will show commands is for CDP to discover subsequent directly connected switches. So will not to exceed a specific hop count during the discovery. We'll click into the fabric. Under Fabric Overview, add action to add switches. This time we're going to enter the seed switch, which is management interface. Get username, password. We'll uncheck preserve config. Then we'll clean up the config on the switches and then click discover switch, confirm. Let's select all and uncheck the external router. I'll click add a switch. We're going to add all of these 6 switches to inside one. Await and get it added to the fabric. Now I'm seeing the switches are added. Let's close the tab. Go to switches. Now we're going to assign the roles to the switches. So this is to ensure each switch has assures with correct role in the fabric. The importance of the roles defines how and what the best practice or configuration templates are used to deploy a configuration to the switches in the fabric. So as part of the building automation and discovery and import, so the system automatically assigns the default roles based on the switch model. So for the Nexus 9300 switches, the default role is set to the leaf, and the Nexus 9500 switches default role is set to the spine. The first role assigned is the border gateway, and I'll take action to set a role. The role we're going to set is the border gateway. When I assign the role for the spines, we'll click the set one as 1 and as 2 for spines, and we'll set a role as a spine. Click OK. Let's take a look here. We have a border gateway 1 as assigned as the border gateway, and I'll have a spine 1 and spine 2. They are all spines. This border gateway. We're going to assign the role for the border leaf. What border leaves the role is going to be we call a border. Find a border leaf, and I'm going to set a role to border. And of course, the default roles for leaf 1 and leaf 2 are the leaves. We don't have to do anything. Check out a diagram here. We have to connect to the border leaf 1/5 on both leaf to server 1 and the server 2. And that's the interface we're going to configure the access to the server. Check side 1 leaf 1, side 1 leaf 2, and we're going to navigate to the interface. And in the future, we're going to enter the interface equals to Ethernet 1/5. Let the filter run, and I'm going to check the border leaf, so the leaf 1 and leaf 2. Where I take action to add it to interface. In the policy list, we're going to select the interface access host. What I'm going to do is save and next. We're going to make sure the policy for second interface on the leaf 2 is also going to be the interface access host. Let's click save. And we'll click deploy. When the fabric controller is going to tell me the expected config for the port, and we're just going to deploy config. I'm waiting the deployment to complete. Deploy completed, and we're going to just close the interface. In the next step, we're going to create a VPC pairing. So I'll perform the site 1 greenfield is to make my site 1 leaf 1 and site 1 leaf 2 VPC pair. So in class OA, VPC pair domain. We'll double click the switches and we'll choose is the site 1 leaf 1. Site 1 leaf 1 is going to pair automatically with my site 1 leaf 2. I take action to create a VPC pair. I will take a VPC pair as the site 1 leaf 2. We're going to pair with the site 1 leaf 2. It's already paired, so I will just give a cancel. What you see here is like the leaf 1 is pairing with the leaf 2, and they're the primary and secondary VPC pair. Next, we're going to create this VRF and overlay or tenant in the VXLAN EVPN needs a L3 VNI for symmetric IRB if I need inter-VLAN routing. The Cisco only supports the symmetric IRB, so if you want to know, just to Google about the symmetric IRB. It's basically routing to between for the layer 2, we need to create a symmetric layer 3 VNI for the L2 VNIs. So L3 VNI is associated with a tenant VRF routing instance that separates the routing domain between tenants overlays. So this is one of the powerful things about the Fabric controller. It automatically automates and provides a health check that all VF, BGP, UPN, and VXLAN configure is correct. So this can be uh, handling in a large production environments in many peers and many tenants overlays. So I create and stage the first tenant overlay VF that are associated with the L3 VNI. So I'll go through the workflow to create the networks that includes the L2 VNIs and VLANs associated with them to an overlay tenant VF. So in the fabric overview, we'll find is the VFs. I will take action to create an VF. The VF we're gonna create is the blue VF. The VF ID is 50,000. So it comes from the pool of VNI I create while creating the fabric. If you remember, if you take a look back, we're gonna to propose VLANs that takes 2000, and we have templates. So we're gonna to use the default VF universal, the VF extension template. So I'll leave it at default also. In the VF VLAN name, we're gonna say is blue VF. Copy it and interface description, and VF description will use the same. So basically, when in here, I was creating a blue VF. The VF ID is 5,000. Sorry, 50,000. Let's go ahead and we'll be creating the VF. Click create. The next thing we're gonna create is the network. Navigate to network. The network in the controller is where we define the L2 VNI that are associated to VLANs for L2 segmentations for the bridge domains over the routed fabric. L2 VNIs will enforce segmentation by not allowing L2 traffic to traverse the VNI boundary. If I need inter VNI or VXLAN routing, the L3 VNI VRF is required. That's why we created before in previous steps. So if needed, we're going to create the SVI or VLAN interface. We'll call any cascade gateway exists all leaves that you create and associate to L3 VNI VF. So if I don't need to route between the L2 VNIs, then the L2 VNI can be layer 2 only. So in this lab, I define two networks for inter VLAN routing associated to the L3 VNI VF I created in the previous step. So we're gonna create here is the uh, L L L3 we just create. Then we'll create L2 is gonna call the blue net 1, and we're gonna call the blue net 2. In each of the network L2 network, and we're gonna have anycast gateway associated with it. Okay, let's take action and create the network. The network name we're gonna say is the blue net 1. It's not L2 only, so uncheck it. VF name, it automatically becomes blue VF. So it already set the network ID will leave it default 30,000. So this is the first VNI from the L2 VNI pool, and we're gonna propose a VLAN ID. So go down here with the IPv4 gateway. We'll say 192.168.1.11.1/24. VLAN name we'll give is BlueNet1, and give an interface description for the Anycast gateway. Let's create my first L2 VNI network. We'll create the next one. We'll create as the BlueNet2. We'll propose that only one VNF, L3 VNI is Blue VNF. Propose a VLAN. We're going to put the Anycast gateway IP. The VLAN name, BlueNet2. Gonna click create. Now create two networks for L2, and we are creating is the VLAN ID and the gateway for Anycast gateway, and VF name was automatically associated only one is the Blue VF. This is what the networks looks like when I finished. Let's come here, and we are creating two network. One is the BlueNet1 and one is the BlueNet2. Then what I make it next is to create an attachment. So in the fabric controller, VF and network attachment can happen independently. So we're going to attach basically the BlueNet1 to attach it to the interface on leaf 1/5 to 1/5, and the BlueNet2 we're going to attach to the 1/5 on the leaf 2. So in this case, I create the VRF and attachment to the leaf switch. Then I'll create network and attachment to the leaf switch. So I can combine the workflow and where I create the VRF and the associated network to the VRF. Then finally deploy network to which deploy the VRF. So all this is subjected to the Cisco best practice. I have staged my overlay tenants VF and stage the two host networks that are associated to my overlay tenants VF in the previous sections. And so this is time we're going to attach this constructor to the leaf switch so that required. So the requirement comes based on the design and how the host, such as if you have has a EXSI and connected to my leaf switches. So there are two standalone there in this case the Linux instance that are connected to my leaf 1 because so 1 and leaf 2 switches to the Ethernet 1/5. This is the interface I use the policy to configure as the access interface leaving the access the VLAN undefined. So another part of the attachment workflow is a selecting interface for the network I deploy, whether it is an access or the trunk interface, because I already configured as access. So that's attached them to my access port E/5 on leaf 1 and leaf 2. Well, double click the BlueNet 1 and network attachment. We're going to check the box for the 1 switch. I'll take action for edit. We're making attach. So we're going to slider to attach. Select the 1/5 for side 1, the 1. we're gonna attach is the bootnet 1. So I'm seeing side 1 leave 2 in this list because the side 1 leave 1 and side 1 leave 2 are the VPC pairs. After that, we're gonna click save. Now it's attached. We're gonna close this. Then we'll double click bootnet 2. Now our attachment. We're gonna pick it is the side 1 leave 2. We're gonna add it. Gonna make attach to side 1 leave 2 1/5. Port type is access as we previously configured. Click save. And we're gonna hit close. At right here, we're gonna hit recalculate and deploy everything. And it's making a recalculating configure on the switches. After all that, we're gonna see auto think for leave 1 and leave 2, and we'll hit deploy all. Now expected all deployments completed. We'll close it. Now we're just showing deployed that when performing the action to deploy the network attachment. So the intent is to my VF to deploy it at the same time because the VF association with the network when I create it. So we're going to confirm VF also being deployed. Navigate to VF. The VF is also deployed. Let's verify side 1 fabric. So the fabric controller I've created and deployed my side 1 greenfield VXLAN UPN fabric, and I'll perform the level of verification and checking the deployment status in the fabric controller. So now I'm going to connect to some of the devices in my side 1 fabric. I'm going to issue some show commands to verify the configuration of the fabric controller deployed by the fabric controller. That's open up my spine 1. I'm first going to show verify the underlay OSPF neighbors, show IP OSPF neighbor. I'm seeing is the point-to-point fabric and the underlay OSPF neighbor to the the switches. Let's see my show BGP-L2 VPN eVPN summary. I'm seeing the the eBGP L2 VPN neighbor. I'm seeing all the neighbors are up, and then we'll go to the side. I want to leave 1. I want to show VPC. I'm seeing the VPC pair adjacency form OK and peer is alive. Let's show on VNIs. We'll create about 1 L3 VNI and 2 L2 VNI. So show NVE VNI. I'll create a L1 L3 as a blue VNF and a 2 to be L2 VNI. Next thing, I'm gonna go to my server 1. I'm gonna to verify side 1 data panel. So there we will have the 2 Linux servers and connected to my leave 1 and Ethernet 1/5 and leave 2 1/5 respectively. I use these to test the inter VXLAN data panel connectivity within the same tenant. The overlay VF to VF is the tenant in my side 1 fabric. So I will ping from the server 1. So I configure app config and I'm gonna ping 192.168.1.254. That one. I'm pinging my on and it cancel gate. And what I want to ping is the other server, the server 2 in the bootnet 2. After a while, it's pinging. Just got a response. Let's take a look at the topology, or navigate back to the fabric controller. Now go to the topology. I'm going to double click the side one green field. What I'm seeing configuration here is a VPC deployed between line one, leaf one and leaf two. And I have the border leaves and border gateways to the spines. So when all the switches are green, they are synchronized, and I can hover over the link and all the switches to view more details. Hello, let's take a look at my diagram again. The next step is to import and deploy brownfields into the fabric controller. This is my site 2 fabric, a brownfield to fabric migration needs me to follow best practice on existing fabric to maintain the consistency of the overlay configurations. Like a greenfield I created same type of Datacenter VXLAN EVPN fabric for the brownfield. And when I create the side 2 fabric, I will ensure that the configuration parameters align with the existing fabric. I will step through this configuration later. So the first step is to navigate the LAN and the fabric. We're going to create the new fabric for my brownfield. The name is side 2 brownfield. I'll choose fabric. It's the same as Datacenter VXLAN EVPN. Select it. Save. Let's don't save it. Then the general parameters. I will need a AS number. 65222 is my AS number for side 2, and we're gonna to go underlay subnet IP mask, so I don't need a 30, just 31. That's point to point. That's enough. Select the replication. We need a loopback interface ID 252 is my RP loopback ID for multicast rendezvous point. And we're gonna click is my resources. So in the resource, I will define IP address pools for the routing loopbacks, VTAP loopbacks, spine RP loopbacks, and physical interface to align with the addressing scheme already used in the brownfield fabric using the value right here. So for the underlay routing loopback, we're gonna make it 22.0.0/22, and the VTAP we're gonna use 222. 10.222.0.0/22, and for the RP loopback interface, and this is for my underlay subnet IP range. So if I'm unsure about this value, let's go to my CLI configure for spine 1. We are going to side 2 spine 1, and we're going to just verify all of this configurations. First, show IP interface brief. I'm show run interface rollback 0. That's what I used for the routing rollback for the OSPF. And we show run interface rollback 252 as the IP rollback. Show run as multi IP PIM. So That's my RP interface 10.252.254.1. That's right, my loopback interface is the 252. And with show around, just check the IP interface for the IP routing /21. It's 10.2.0.0/16. It's all the ranges including the IP address. So go back to my fabric controller or general parameters, fabrication, IP, resources, that matches everything we have in the existing brownfield fabric. We'll give it a little bit of score down. And we're going to find the VRF light subnet IP range. So we're going to change it. Change 20.33.0.0/16. After all that, let's click save. There, one thing I want to change is the side 1 green field. Go to side 1 green field and add it to the fabric. Navigate to resources and double check all the interface we created already. And we're gonna navigate down there. Now make sure it matches the VRF light subnet IP range. It's on the subnet 1, the side 1 and side 2. They are all using this P2P in the fabric connection subnet. And for the side 1, we're gonna check one more thing. Go up here, even we choose VF light deployment, we're gonna check auto deploy for the peer. And we'll click save. So it tell me to redeploy it. I will do that. Sorry, I'm still dealing with the side 1 here. I have to click ring to synchronize. That's all synchronized for the side 1. That would we're fine to deal with side 2 brownfield. Let's double click into the side 2 brownfield. What I want to make sure is go back here and we'll double check the fabric, configure it again. Go back to resources, make sure the subnet is changed to 20.33. So what I mean is here, that's the 10.33.0.0. Here is the 20.33.0.0. That's what I wanted to configure. All right. Okay, now we're okay to add our switches. Going to the side 2 brownfield, so I'm gonna add the seed IP. Seed IP 198.18.04.201 and password, username password. I will make sure the preserved configuration is the toggle to yes. And I want to click discover switches. and that will help me to discover 3 switches, leave 1 spine and a border gateway. We're going to click button and add switches. After adding is done, I'm going to close. Let's navigate to switches. We're going to set the side 2 border gateway, our new row, to it is the border gateway. And for the spine, it's going to be the spine. Now the rows have been set, and we're going to click recalculate the port. This is going to generate the required configuration based on the configuration of best practice per role and template. And the user input created fabric initially, and it is all brownfield configuration. So I'm now seeing any lines for configuration are required to configure my brownfield fabric. So that's that's aligned with my NetMaven dashboard fabric controller. We'll close it. I'm seeing my brownfields configuration are in sync, more than normal. The configuration status shows success. We're going to review the VRFs. We're going up to the VRF. I'm seeing the red VRF is the port. The red VRF is the VRF we imported. And we're seeing the VRF, a VNID, VRF ID. It's also called VNID of 59,000 is inside the range 50,000 to 59,000, and I'm seeing the VF attachment. So the red VF shows the port to my side 2 leaf 1, and I have the VLAN 2299 that resides in the VLAN range from my side 2's fabric settings. Range is 2000 to 2299. Let's close it. I'm gonna review the networks. In the network, what I'm seeing is a AutoNet VNI as a prefix. This name signifies the network that is imported as part of our brownfield import. So I noticed that the VNI 49,000 and VLAN 2999 resides within the network VNI and VLAN pools respectively from the fabric setting. Then let's verify in the CLI. What I want to verify is on the spine to show BGP-L2 VPN EVPN summary, the neighbor with the leaf and the border gateway. Let's go to my side 2 spine and show BGP-L2 VPN EVPN summary. I'm seeing the 2 neighbors. So CDP neighbor, one to the BGP, to border gateway, and leave 1. The next step we're going to create is the external L3 connections to the non-VXLAN fabric. What we're going to take a look at is the extend L3 fabric is an external connectivity from the data centers, and this is the non-VXLAN fabric is a prime requirement. So the VXLAN EVPN based data center fabric, like the we created green fields and brown fields, provide east to west connectivity, the east to west connectivity, and by distributing the IP and MAC reachability information in VXLAN. So in my greenfield fabric, the border leaf switches like the BL1 and provides external L3 connectivity using the VF light or connecting out of the fabric. So these steps show you how to create the external fabric that is required by the controller to extend the VF to an external fabric device. So the fabric controller will create the external fabric and manage the external devices if they are the Nexus 9K, 7K switches, or we'll say if it is the ASR or it's the NCS. So they are the NCS, ASS routers. The controller not only will generate and push the configuration that is required for one or more leaf switch, acting as the border leaf role, but also maintaining a platform configuration. It's going to be a configuration compliance. So let's create this external L3 fabric. We're going to see we already created side 1 and side 2 greenfield, brownfield. We're going to create a new fabric. We're going to name it as external L3 fabric, and we'll choose the fabric type to be an external connectivity network. The AS number is the 65333, and we'll click uncheck is the fabric monitor mode. We wanted to deploy a configuration. So I'm gonna click save. Is as simple as that. We're gonna to double click L3 extended fabric, and we wanted to add more switches. So the switches, we're gonna add a C switch. We're gonna discover switch. We're gonna discover external router. This is the switch we're gonna discover or could add. We're adding the switch, and it's running the process, and we're just wait to be added. Now switch added, we'll close the tab, and we'll go to switches. Next thing I want to check the switch. I want to set a role for this external switch. The role we're gonna set is the edge router. I'm gonna select it. Click OK. So after that, we are going to recalculate and deploy. Once the configuration recalculates and showing out of sync, we wanted to deploy all. Now we'll deploy external L3 fabric to border leaf in the side 1. So when I created the border side 1 greenfield fabric, I set side 1 the fabric setting under resources to provision VIF light externally and to auto deploy both the sub interface and BGP configuration for external connections. So my border leaf and external router, as I saw when I created my external L3 fabric, have detected each other. So the provision of the sub-interface and BGP configuration can occur for both. We'll click cancel this, go exit it. We're going to double click my side 1 green field, and we're going to synchronize side 1 with the controller. And synchronize it with the new external L3 fabric. So in the top fabric level action drop down here, we're gonna recalculate and deploy just because we just added the external L3 fabric. So this synchronization as in performing some automation configuration and deployment from the side 1 VXLAN UPN fabric to external L3 fabric, external routers by staging the IP address for use on the sub interfaces between the border, leaf, and external router. So after I click recalculate and deploy, I notice that no configuration changes are made and push the switches in the side 1 fabric. So again, this is just purely to sync side 1 with existence of the external L3 fabric. Where click close. We're now in the fabric configuration page. We'll check is the VF. So we're gonna to edit the VF attachments. So because I now wanted to extend my tenants to overlay externally out of my side 1 fabric, we'll return to VF and deploy my blue VF to my side 1 BL1, the border leaf 1. So previously I only deployed this VF to my side 1 leaf 1 and side 1 leaf 2 through the attachment of two networks to the server's access interface. So we're gonna to attach it to the border leaf this time. We'll double check the blue VF and the VF attachment. To find out the side 1 BL1, check it, and we're going to make edit. Going to attach to it, and we're going to extend this with a VF light. And in the extension table at the bottom here, I see that interface connecting to my border leaf and external router are automatically detected. And with both being 1/3, the IP addresses are allocated from the VF light sub interface address pool. Remember the address pool 10.33, and that is defined in the fabric settings of my side 1 fabric. So the BGPS number that I defined in the external L3 fabric is also populated right here. So this part we're going to detect the E13, E13, and the BGP number is all in right here. Okay. Notice the edit here. Click edit. In the extension details, I will leave everything as defaulted, and the controller will pull the parameters values from the VF light sub interface and IP address pool in my side 1 fabric, and these two actions I must take is to enable the extension. So just toggle here, and let's save it. Now it's showing attached, and scroll up. I will say the whole thing is attached, and I change the extent to VF light. I will save it. Now appending attachment to the border leaf 1, we're going to deploy it and an action or make it deploy. deploy. So this starts deployments to my blue VF to my border leaf. As those same deploys, well, go exit. I go back to Fabric overview. What I'm seeing here is extended network. I have one extended network and VF deployed. Now we're staying at site 1 greenfields. Looks like everything is deployed. But if we go to extend R3, I'm seeing the pending configuration of one switch is still there. And we're going to enable between the fabric and switch types to enable configure external connectivity for the VXLAN VPN fabric. So we're also going to manage the external devices in the Nexus dashboard fabric controller. So we're going to trigger the deployment. So first we're going to go to the switches. And we're going to click action. We only have one switch. We're going to action deploy. We're going to deploy all. So the controller has various policy templates available to me. So use these templates to automatically provision when I deploy my VXLAN EVPN fabrics. So I use the policy templates for my own purpose and to achieve outcome that I require in my network when I deploy and making a configuration change. So now the configuration is deployed, only part of it. So next we're going to use a BGP network statement template to inject the prefix from my external router into my border leaf and into my fabric and to test external connectivity later. So close it. We're going to advise external router. So in the policies, we'll click the add one policy. The policy we're going to add is to the external router. Click next. So when the external router is selected, we must select the appropriate policy template and from many of the available by default in the controller for various use cases. So we're going to select the template. We're going to find the templates called BGP BIF network. Okay, select it. We're going to say the BGP itself, this AS number 65333, and I want them to match existing VF configured on my external router. And in my site 1 VXLAN EVPN fabric, we're going to name it as the blue VF. So we're going to select the blue VF. The prefix to 192.168.20.0/24 to match the network of server 4. The server 4 resides in right here. It's a network stack 20.0/24/24. We then click save. Now in the top we'll click switches. In the action we'll make deploy. I'll click this action, I'll make a deploy. Now I have 5 lines to deploy to advertise the network for the server 4, and the VF is the blue VF. I click deploy all. Deploy completed, we'll close it, and I'll navigate back to my CLI. In the CLI, I will open up my external router and so forth. External router, we're going to show IP route. So IP route has nothing. Show IP route VF. We'll create a blue VF. In the blue VF, we'll receive the 2 subnets through the border leaf. The one in that 192.168.11.0 and 112.0 /24. They are the 2 BNIs for VXLAN, bootnet 1 and bootnet 2. And if I go to my border leaf, the border leaf I'll show IP route VF, blue VF. Let's see if I'm gonna receive. I receive a 192.168.20 for the server 4 network from the external router. That's what I receive on the border leaf. So let's go to my server 1. Let's give it a ping to my server 4 IP. Upload is the 192.168.20.4. Not quite sure. So show IP config, IF config. Yeah. So I'm gonna ping from server 1 to server 4. Let's see. The ping got response. And server 1 is connected to leaf 1 and server 4 connected to the external router outside the VXLAN fabric. So to the diagram, I'm seeing the ping is able to go over like this. The traffic path should be like this. From server 1 to the border leaf and to the external router and server 4. Now let's take a look at the next step, which is import and deploy an ISN fabric interset network. With my site 1 green fuse and site 2 brown fuse created and verified as configured and functioning correctly, the next step is to move them into the multi-site domain. We're going to call the MSD, multi-site domain. So first I must create the fabric for the routers that act as the inter-site network, providing connectivity between my data centers. So again, the controller can fully manage these devices as well as the fabric, similar to previous external 3 fabric. This time, it will be the core router. We use 1/1 to the site 1, 1/2 to the site 2. Very simple setup for interset network. We're going to navigate to my LAN fabric. I'll create a new fabric. This fabric is going to name it as ISN. And we'll pick a fabric as type multi-site external network. So AS number 6544444444. We'll deselect fabric monitor mode. I'll click save. Next, similar, we're going to add the switches. The seed switch is my core router. So we don't need a hop, directly connected to the core router, discover switches. We discover core router and we'll click add a switch. The switch is now added, so we'll close the tab. We're going to make a recalculate deploy. Finding 2 lines out of sync and we'll deploy all. Let's close it. Also close the whole thing. We'll go to topology and we'll change the mode to view the configurations. I'm seeing the ISM fabrics created. It's connecting to my side 1 and side 2. The next thing was to create the multi-site, and we'll create multi-site fabric using multi-site templates in the fabric controller, and I'll import all 3 fabrics with an easy to use fabric controller GUI, and we'll ping between the servers in the 2 different sites, and it confirms that multi-site is configured successfully. So let's go to the LAN fabric. I'm creating a new fabric. The fabric we're going to create is an MSD-1 multi-site domain. We're going to choose the fabric. It's going to be VXLAN VPN multi-site. I'm going to select. There's a bunch of things we're going to config. So the Datacenter interconnect parameter specifies how to configure the DCI, and I can deploy the multi-sites overlay into fabric connectors IFC manually and using the root server or directly to the border gateways. So in my lab, I deploy multi-site overlay IFCs directly to my border gateways in my site 1 and site 2s. I don't have a route server, or in this case, it's we call it super spine. I'll make another video about how to use a super spine multi-site. And so in this lab, we just directly to my border gateways in the site 1 and site 2 fabrics. Also, I'm going to enable automatic deployments of the underlay configuration for the IFCs to my core router, so I don't have to perform that operation manually. So let's configure DCI. In the DCI tab, we're going to find the multi-site overlay IFC deployment method. It's going to be directed to the BGWs. So go down here, we'll see, find the multi-site underlay IFC automatic auto deployment flag. We'll click that. And that's it. So we're gonna click save. We'll go to the MSD. We'll find I have a child fabric. Let's go to child fabric. We're gonna take action to add fabric into my child multi-site domain. So First, what I'm gonna make is choose site 1 green fuse, and I'm gonna select. Okay. I'm gonna repeat to add site 2 brown fuse to my MSD. Click OK. So we added to site 1, site 2 to the MSD. We're gonna recalculate and deploy it. So the configuration will apply to BGW only routers and the core routers. So what I'm gonna mean is we're gonna make a config to this router, and I'll make a config to this router, each site 1 and site 2. I'm seeing the many lines config right here for the multi-site configuration. We can review them carefully. I can talk about the config added here. The EVPN multi-site border gateway. That's make sure the site 2 bar gateway. This E1/1 is facing internal fabric, so it's fabric tracking for multi-site. We're going to scroll down. So look at how I created loopback interface 100. The 100 is advertised into the OSPF, and we'll have matching a tag to it. So we're using this for the border gateway interface source IP in the BNI, L3 BNI here. Host reachability, we're using BGP instead of multicast. So this is the B. So that's the loopback 100 is the border gateway VIP in the same site, and so a site's maximum support for BGW, they will share the same IP. What I mean is, like in here, we could have 3 or 4, with maximum 4 border gateways, and they were all sharing this loopback 101 interface, right? For redundancy, okay, and the border gateway interface 100. This is to make sure we have to select the best border gateway to communicate with the ISM, and we'll share the same IP, and we're going to advertising to the OSPF. So we receive the tables changes to the next hop, the BIP, so it must be in the OSPF. Keep scrolling down. So I'm matching the loopback interface for the gateway VIP, and we'll advertise into the BGP. We'll have neighbor, and we're going to rewrite the RT-AS number to the local AS number, one standard community. The peer type here is the fabric external. So it's external interconnection. The BGW changes the next hop to the VIP as border gateway device. Clears that. Similar configuration for the site 1 BGW. Let's deploy all. Oh god, deploy, close it. Let's go to my fabric overview. You don't see anything. Okay, we exit it. Well, we're gonna see the sub fabric, what means the child fabric see hidden here under MSD. Then, as previously mentioned, after I added my existing fabrics that add child to the parent MSD fabric, I make network changes from MSD fabric. So in this lab, I extended my blue VNF tenant overlay, which is the L3 VNI across sites to my site 2. So remember my site 2 upon the brownfield import only had the right VNF tenant overlay. So I can also extend the L2 VNI network segment to site 2 from site 1. I see how easy it is going to be without going multiple fabrics or doing this in the CLI. So let's go to my MSD interface. We're going to enter a filter for interface equals to 1/5 Ethernet 1/5. So find out site 2 leave 1/5 interface. We're going to click action, edit. Edit, we're going to select the interface access host. Then we're going to select, click expected. We don't select anything, I'm going to just save it. That's deployed. We'll click deploy config. Then we'll click deploy. Same marker and close can deploy it. Or take a expected config. Check it. We just close it and we'll go to MSD, navigate to networks. With double click the blue net 1. The network attachment, we're going to select site 2, site 2 leave 1, and we're going to site 2 leave 1, site 1 BGW1, site 2 BGW1, and to take action, edit it. We'll make attach. Then we'll check the box next to Ethernet 1/5. And we're going to click save and next edit. Click again. Back appears. Click save. Now I'm seeing the pending configuration. We're gonna go action. We're gonna select them and we'll say deploy. Click deploy again. Now the network status shows in sync. Close it and close everything. We're going to navigate to topology. Let's click the We're seeing the MSDs is multi-site domain between site 1 and site 2. Let's click site 1. Now I'm seeing the topology as this. In 2 VF, blue VF, red VF, and the networks. There's one more step we're going to do is we're going to add it to MSD, add a fabric, exits, double click MSD, child fabric. We're going to add the ISN fabric to the MSD. Then we'll click. Recalculate. Exit. Go to site 1, do a recalculate. Site 2. And go to ISN. And we will go to the ISN fabric. One thing I'm gonna change is the switches. I forgot to set a role for the core router. So the core router role is gonna be core router selected, and it becomes core router. We're gonna redeploy. So after that, we'll close it. So nothing to configure as it's just changed to core router. We're going to go to my MSD fabric and we're going to redeploy. We're going to recalculate and config and deploy a new one. So they're going to find out what's going to happen on the border gateways while I'm missing configs. So 21 line is going to add, they're going to add a configuration to the core router. So the core router configuration is going to have a BGP neighbor with the core router here. It's just look at what it's going to configure the IP interface, and it's going to set up a unicast IP is BGP v4 BGP relationship with the core router. So I would deploy all. Gonna wait everything to be deployed. Let's now navigate to my core router, show IP BGP summary. I'm seeing the BGP neighbors from my BGW1 and BGW2 in each site. And if we go and navigate to BGW1 and show IP BGP summary, I'm seeing BGP neighbor has been established. Show IP route BGP. So now if I go to my server 1 and I'm pinging my server 3, the server 3 I've config is setting at the same VNI, that's bootnet 1. So we're gonna ping from server 1 to server 3, and I'm getting a response. What I try to ping is server 1 is gonna ping to through the multi-site ISN domain, multi-site domain to server 3. So for the next step, I'm going to migrate classic Ethernet environment to the VXLAN BGP VPN. So migrating a brownfield network consists of the connecting an existing brownfield network. So the steps are going to be migrating. We're going to design and deploy a new VXLAN BGP VPN environment, which is the greenfield. We have done that. So we'll integrate with existing data center infrastructure and new VXLAN BGP VPN fabric. The L2 and L3 connectivity between the two networks is required for successful application and workload migration across the two networks. So we already done that between the multi-site. And next, we'll configure two connections from the leaf 1 and leaf 2 to an external router, and for a layer 2 connection using a VPC domain that is configured on the leaf 1 and leaf 2. Our configure is the VPC domain is already configured. And for the server 4, and the first hop gateway resides on the external router. The external router is the gateway, so we can configure layer 2 network on both the leaves during migration of reachability through the L2 links. Then we'll deploy L2 network on both the leaves. When we move the workload from the leaves, then we convert network to L3 with Anycast gateway residing on the leaves instead of the external router's network. Instead of moving the server 4 to the leaf 1, we connect to the server 5 on the Ethernet 1/7, which is the same network of the server 4 to simulated migration. We already created the VPC domain. The next thing we're going to create is the VPC interface. So we'll double click the site 1 greenfield fabric. We're going to exit all of that. I will navigate to the interface tab. The action is to add view interfaces. Type we're going to make is the virtual port channel. We already have the VPC pair. The interface we're going to make is the interface Ethernet 1/6, peer 2 is Ethernet 1/6. Let's double check my diagram in 1/6 is what I'm going to config. And next, BPDU, we're going to make a false. And port fast. We're going to uncheck port fast because I don't want it port fast here. So we're going to allow a few VLANs here. Peer 1 trunk allow VLAN, we say 20. VLAN 20. Let's save the config. I guess here we're gonna just say 20. Save it. It's gonna save the config. Now we're gonna make it deploy. So one line, few lines to deploy it. Now I'm seeing the VPC interface deployed. We navigate to MSD interface, so I can just do interface filter. I want to see that interface. Now I'm seeing the VPC1 interface on the VPC channel. And let's search again in the main interface. In the VPC interface remains like, is it down? Yeah, it's down. So, but this shows consistent between the side 1 leave 1 and side 1 leave 2. With side 1 leave 1 will show VPC. I'm seeing the port channel 1 is down, but like good things it's consistent. So what we'll do next is to go external L3 network. We're gonna create a small port channel. On the interface, we'll create a new interface. It's port channel for sure, so external router. Make a policy should be port channel trunk host. Select that. So port channel member interface, we'll take a look at the E12 and E14. E14 to interface. Port channel mode active. We don't enable BPTU guard. Not a port fast. We are going to allow VLAN is 20. Save. Deploy it. Now we deploy everything. Let's go to the external router. Let's say show VPC. Alright, this time we're going to go to the leaf, show VPC. And the VPC shows up, that's good. And external router, I'm going to show port channel summary. My port channel on the external router is also up. So next, we're going to config this interface 1/7, which is connected to my server 5. That's on my leaf 1. Alright, so this is gonna submit after everything is migrated. We have a new server 5 connected to the directly to the leaf. What we're gonna do is close out that. So I know it's the side 1. We're gonna double click side 1, go to interface, we'll find that interface equals to Ethernet 1/7. we're gonna find the side one, leave one, side one, leave one, and we're gonna to edit. Gonna be an access host port policy. We're gonna save it. And we'll click deploy. After that, we successfully deploy. We can double check it. Show run interface Ethernet 1/7. It be deployed as a access port. We're gonna create some network for the external network. Let's first exit the child fabric. Go to MSD, and we'll go to network. We should create it in the multi-site domain level. I'll create a new network. The network name is external network, just like that. And L2 only. It will be L2 only check that. And network ID will keep it default. VLAN will make 20. Create. Then we'll double check this. So double click this newly created external network. Find network attachment. We're gonna click the box for side 1 leave 1 and side 1 leave 2. And we're gonna say edit. So we can attach VLAN 20 to the side 1 leave 1, side 1 leave 2. Click save. We have printing configuration. Let's deploy it. Deploy. So all deployed. We're gonna open up my side 1 leave 1. I will show MAC address table. I'm seeing MAC address from the port channel on the VLAN 20. Seeing list, still not associated to E1/7. So now we get back to my dashboard controller. Let's find out the side 1 leave 1, and I'll make edit. I forgot to side 1 leave 1. I'm gonna search. Oh, it's right here. So side 1 leave 1 on port 1/7. We're gonna attach to VLAN 20. Click save. Now I'm seeing the interface. Gonna deploy it again. So that's all the ports. We'll show the VLAN config on this interface again. So MAC address, I'm seeing port 1/7. It's on MAC address table and VLAN is 20. Then open up the server 5. Now we're gonna to ping the gateway. So let's take a look at what IP configured. Okay, just ping the gateway. I can ping the gateway, no problem. So to complete the migration, we're gonna disable the gateway on the external router and enable L3 network. So that's navigate external router, make some config, interface VLAN 20. We have the VLANs right here. We're gonna make shutdown. Then let's migrate the gateway. I'm pretty sure my server 5 cannot ping this again. It's not going to ping or shut down the gateway. So let's go to the MSD again and the network. We're going to check external network. These will be, I'm going to edit the external network. For editing it, we're going to find out is the L2 only. We're going to uncheck because it's not going to become L2 only anymore. The blue, keep selecting the blue VF is inside one. We'll find out this IPv4 for gateway. Applying the new gateway to my fabric and check save. Now let's save it. Then we'll check the box here, and what I'm gonna do is recalculate. Doesn't look right. Gonna do deploy. Alright, see what's pending. Okay, it's putting on a gateway. Good. We don't use recalculate. Let's just deploy it in the lower here. Okay. Now I'm seeing deploy it. Let's go to my, okay, the server file can ping anymore again. So we'll fulfill migration. I don't configure everything as we did in this lab, as network in the VXLAN VPN already exists. So accredited and associated with the interfaces, I only must configure the leave port to the right VLAN, which that connects to the server once the migration, and for each VLAN I migrate. Then I would test it and ping. It's all pingable, right? So for the next lab we're going to do is to configure endpoint locator. So we enable the endpoint locator feature in the Fabric controller, which helps us locate endpoints that are connected to the leaves. So this is useful when have to troubleshoot and locate one from 100 thousands to the endpoints inside your data center, right? So the endpoint in locator EPL feature allows real-time tracking of the endpoints within a data center. This includes tracking the life history of the endpoint and providing insights into the trends associated with the endpoint's additions, removals, and moves, etc. So the EPL feature relies on the BGP peering established between the fabric controller and the root refactor. So after you establish the BGP session, the NDFC, the fabric controller, receives the BGP updates from the root refactor with the endpoint information. So the endpoint locator provides almost real-time tracking of every endpoint. Events such as a endpoint coming up, an endpoint going down, or an endpoint move are now visible with a few simple clicks. So let's config a leaf Ethernet 1/3. Leaf 2 is now 1/3 interface, which is connected to NDFC data interface with like side 1 leaf 2. We have interface connected to the data interface of the NDFC. Its interface is 1/3. Okay, so we're going to go to LAN and click MSD 1. We'll go to interface. We're going to say the device name equals to side 1, leaf 2, and we're going to find Ethernet 1/7, leaf 2, we find out 1/7, and we're going to click action added. In the policy, we're going to make is the EPL routed interface. Gonna make IP. And go down to the freeform config IP router OSPF. We're gonna say underlay area. And we'll go to save. And we're gonna deploy it. Click deploy. Close it. And let's double click side 1 green field. Fabric overview. Here we take action. We're to more, and we're gonna configure the endpoint locator. In the endpoint locator dialog, we will check configure my fabric, and in the RR1 we'll select side 1 spine 2. In collect the additional information, ports, VLAN, etc. we say yes, then we save the config. So after a couple of minutes to configure, the endpoint locator will populate to endpoint activity screen. So the two server 1 and server 2 located on the leaf 2 and 3 will be showed up. So now it's showing up. I made a mistake. It should be the 7. Sorry. I erase it. is the port 1/7 on the leaf 2. So that's the L3 interface. And if I go to side 1, spine 2, I'm seeing one more BGP peer here. It's the NDFC network controller. Now let's click the dashboard. We'll dashboards here, dashboards. We'll click is endpoint locator. I'm seeing the locator right here, the endpoints. More pages showed up. I'm seeing the 192, 168, or 12 to 22. This is the server 2. We'll click the endpoint. Right here. Click it and scroll a little bit down to end live. I'm seeing the endpoints are live or not on the switches. And it's showing me on which VNF, which a VNI ID. It's all showing up here.